In this video, we're going to look at solving some equations that require a little bit more work. They're going to require more than one step. And if I have a problem that's going to require more than one step to get the answer or to rewrite it in terms of x, it brings up the question as how do I know what I'm supposed to move first away from the x? Well, it's a simple way to remember it is that if I want to evaluate, mean plug a number in and get its value. You do PEMDAS. If I am going to solve an equation, I do PEMDAS backwards. I do it in reverse. So I start with, first of all, when I'm solving, is I attempt to move, I'm looking outside of parentheses, I attempt to move any kind of addition or subtraction away from the x first. Anything that's adding or subtracting, I try to move first. And then once I've moved all the addition and subtraction, I then work my way backwards to the multiply and divide part. So I want to move any multiplication division that's on the x next. And then working my way to the next part is the e. I'd look to undo any exponents, which we won't worry about that today. And then lastly, you'll be in, if you have parentheses, to undo the parentheses. And if you've worked your way all the way through that order and you still have items left in your equations, then you start back over from the very beginning. And then you repeat all the steps again. And so we have some examples here. First problem, I have 2x plus 3 is equal to 1. Now remember, you have a balanced equation. And so I'm going to draw my little mirror line right here. And first thing I look to move is any adding and subtracting. So I have that plus 3. To move the plus 3, I got to subtract it from both sides. And I do that. The plus 3 is no longer on the left. Leaves me with 2x is equal to. Now, negative 1 minus 3 is negative 4. Now I'm looking at my left-hand side again and say, well, the only thing left attached to the x is the 2. Well, the 2 is multiplying to the x. So to get it off, I'm going to divide both sides by 2. And that gives me x equals negative 2. My next problem here is 3x minus 8 is equal to 4. And so trying to rewrite as x equals. Look to move any adding and subtracting. Well, I currently have the 3x being subtracted by 8. So to move the 8 to the other side, I have to do the opposite operation, which means I'm going to add it. In doing so, that will leave me with just 3x on the left equals 4 plus 8 gives me 12. And now I'm looking to take the 3 off the x. So the 3 is currently multiplying to the x. So to undo multiplication, I have to divide. So I'm going to divide both sides by 3. So the 3 is now off the x. And that gives me x is equal to 12 divided by 3 is 4. I'm trying to get it to be x equals. And I'm looking, I don't see any adding and subtracting. So there is nothing to move to the other side in terms of adding and subtracting. I have everything here multiplying to the x. And I want to figure out, well, how do I get that stuff off the x? I can, in fact, do this problem in one step. Anytime you have x being multiplied by a fraction, I can undo the multiplication by the fraction. Instead of dividing both sides by a fraction and have to deal with skip, change, flip, division is really the multiplication by the reciprocal. So what I'm going to do is I'm going to multiply both sides by negative 3. I'm going to flip that fraction, negative 3 over 2. So I do that to the left, and I'm going to do that to the right-hand side. When I do that, multiplication by the reciprocal is going to take that fraction off of the x. So I have x equals, and now I'm looking to multiply 3 times negative 3 over 2. I may put that 3 over 1, multiply two fractions, bottom times bottom and top times top, which is going to give me negative 9 over 2. Here, absolute value of x is equal to absolute value of x minus 3 is equal to 1. And I want to solve it. Now, when you're working with the absolute value problems, before you start trying to determine whether or not it's even possible to get an answer for x, you have to isolate the absolute value. So I got to move everything away from the absolute value first. So I move that minus 3 to the other side, which means I have to add it. And I do that. The left side has the absolute value of x. I write my equal sign. Negative 1 plus 3 is positive 2. So the absolute value of x is equal to positive 2. That's possible because the absolute value has to equal a number 0 or bigger. So now that I have the absolute value isolated, what you're going to do is you're going to make two little math problems. You're going to take what's inside of the absolute value, in this case x, and I'm going to set it equal to, in this case, the 2. And now I got to make a second little math problem. I got to take what was inside of the absolute value, which was x, and I'm going to set it equal to, in this case, negative 2. So the same number, but negative. So I have two answers, 2 and negative 2. 2 times the absolute value. So I have the same strategy here. I need to isolate the absolute value problem, absolute value function. So to take that 2 off of the x, you don't want to multiply it inside. Anything that's outside of the absolute value, you just move it away from it. So I'm going to divide both sides by 2. It's going to take the 2 off the left, leave me with the absolute value of x is equal to positive 2. Now, the absolute value in this problem is set equal to a number that's 0 or bigger, so I can continue. So I'm going to make two little math problems. I'm going to take what's inside of the absolute value, which is x. I'm going to set it equal to the 2. So one possible answer is 2, because the absolute value of 2 is positive 2. And then I'm going to do the same thing. Take what's on the inside. I'm going to set it to the negative version of the right-hand side of the equal sign, which is negative 2. And then you just think to yourself, be like, okay, the absolute value of negative 2 is also positive 2. So I have two answers. The absolute value of 3x plus 1 is equal to 4. Well, I have to start this problem by moving everything that's on the outside of the absolute value to the other side. So I'm going to minus 1 to both sides. This is going to give me the absolute value of 3x is equal to 3. Now, I don't want to jump right in and divide by the 3 next. Now that there's nothing else left on the outside of the absolute value, you're going to split this problem into two little math problems. So, and I also had to check that's a number that's 0 or bigger, so that I would continue. And I'd write 3x is equal to positive 3. And then I write my second little math problem, which take what's on the inside of the absolute value, which is 3x, and set it equal to the negative right-hand side, which would be negative 3. And then solve these two problems for x. So in both cases, I'm going to divide both sides by 3 to get x all by itself. So this gives me x equals positive 1, and do it again on the right hand side. Divide by 3 gives me x is equal to negative 1.